Okay, so in this tutorial here, we'll be looking at using an oxygen gas sensor. This time, instead of using our GLX probe, I've connected our oxygen gas sensor directly to a Bluetooth Airlink. This one here will be able to talk to the iPad app. This is the Pasco SparkView app here. And basically, we can do all our graphical analysis, data collection here directly on the iPad. So just like before here, we're going to toggle over into sensor data. Because we are Bluetooth connected, it's going to do a quick search of other additional Bluetooth devices. You can actually connect multiple sensors to the same app at any given time. Just make sure the one that's connected here has the appropriate number. So this is 825592. We see that here again, 825592, so that's a good match. It detects that it's an oxygen gas sensor here. Again, you can play around with the different templates for the pages here. Maybe for this time, I want to show it with the table and the graph here. Okay. And this is good a sample for me here. As it takes time readings here, what is the oxygen gas sensor reading? How much oxygen is there present? On the right-hand side here, graphically here is plotting the oxygen gas percentage as the time ticks forwards. So just to simulate this a little bit here, I have 3% hydrogen peroxide, about 50 milliliters of this. I'm going to be dropping in the catalyst. This time we're going to use is MnO2. As the reaction happens, decomposition is going to release pure oxygen. I'm going to try to seal it up as quick as we can, and hopefully we can track how quickly this oxygen here is being generated. So let's just get ready to do that there. I'm going to plop down a little bit of manganese dioxide here. So we'll just drop that in. Okay, nice black powder. We're going to seal it off as quick as we can, and then press the start button. Okay, and it should be able to track for us the change in concentration as time goes onwards. Oxygen in our just atmospheric air should be a little bit less than 20% here, but as we're producing pure oxygen here, as that oxygen is getting detected, we see quite a quick change in our graph there. Because it is pure oxygen that's being released here, it's just one gas, you can actually do some nice molar concentrations with it there. We can track rate versus time. What's the concentration of O2 that's being generated? And now here we're hitting about 46, 45, 50% oxygen. Okay. And we'll just let that go for a little bit here. As long as qualitatively we still see it's bubbling, it's still generating oxygen gas for us. Okay. And as it starts steadying out here, there's not as much peroxide to decompose. We should steadily see this slope dropping away. Again, it's 100% pure oxygen here. You can do a glowing splint test. Basically, the splint that's practically out here, if you just put it back and forth into this pure oxygen solution that's being created, it should be enough oxygen to completely relight the splint. Okay, a nice test for oxygen that's being released. So you see that graphically, this is sort of leveling off a bit for us here. Okay. We can do analysis like what was the instantaneous rate and average rate here once you analyze this data. Thanks, guys.